Good morning to all of you. I am Kiran Pachlasia, Assistant Professor at Sagar Institute of Research and Technology, Bhopal, the SAGE Group. As previous, we discussed on compiler designing on various type of parser. Please go through that video so that you can easily understand today's topic, that is LL1 parser. This is the topic of the subject compiler design. What is LL1 parsing? Actually, LL1 parsing is nothing but it is a top-down parser where first L represent the scanning of the input will be done from left to right manner. The second L shows that the parsing technique which we are going to use leftmost derivation tree. And finally, 1 represent the number of look ahead, which means how many symbols are you going to see when you want to make a decision. So what are the conditions or steps for doing LL1 parsing? The first step, first you have to check the left recursion in the given grammar. So what it means about left recursion, we will see in an example. Second, we have to see that the given grammar should not be ambiguous. Third, we see the grammar has to be left factored in so that the grammar is deterministic grammar. About ambiguous grammar, what is ambiguous grammar? When more than one parse tree is derived, that type of grammar is known as ambiguous grammar. So here in LL1 parsing, the grammar should not be in ambiguous form. Left factoring, we have seen the deterministic grammar. Algorithm for constructing LL1 parsing table. Number 1, first check all the essential condition mentioned about. Go to step 2. What are the essential conditions? First is the grammar is in not left recursive. Second, the grammar not in ambiguous. Third condition, there should be no left factoring. After that, if these conditions are not in the given grammar, then we calculate the first and follow for all the non-terminals. How can we calculate first and follow? So if we are calculating first, if there is a variable and from that variable, if we try to drive all the string, then the beginning terminal symbol is called the first. We can see in an example. Second, follow. There are 3 conditions for seeing the follow. We can see in a given example so that it would be much easy for you to get first and follow. Suppose this is a given grammar. S produces small a, capital A, capital B, small b. A produces C or epsilon. B produces D oblique epsilon. So if we are doing LL1 parsing for this grammar, first we have to check if there is left recursion. Left recursion means a symbol that produces itself of the leftmost side of the RHS. If suppose S produces SAB, so there is a left recursion. But here is S produces A, B, B. So here is no left recursion. In second production, if A produces capital A, then there is a left recursion. But here A produces small c or epsilon. So here is also not left recursion. Third, B produces D oblique epsilon. So here also no left recursion in the grammar. Hence, this grammar is This grammar has no left recursion, so we don't have to modify the grammar. Second condition, if common prefix are there in the production, that is called left factoring. Here there is no common prefix, so this grammar is not left factorized. Third point, if more than one parse can be generated from this grammar, so this grammar is not ambiguous because single parse tree is generated from this grammar. So there is no left recursion, there is no ambiguity, and there is no left factoring. So we have to jump to step number 2. And what is step number 2? Step number is 2 is to calculate first and follow set. Now in first, what we have to see, first of S, first of A, and first of B. What is first of A? S. First of S is first terminal which S produce. The first terminal which S produce is small a. So the first of S is small a. Next, the first of capital A. First of A is C and epsilon. Third, first of B is first terminal we got generated from B is D and epsilon. Hence, we can get the set of first. Now, for the given grammar, we have to get the follow. Follow has three conditions. First of all, every starting symbol must include dollar symbol in its follow. So starting symbol is S. We have included dollar for this S. Second point, we can see in this right hand side production where is S. There is not S in all of these three production. So follow of S is only dollar. Now what we see, follow of A. So how can we evaluate follow of A? We see right hand side production. Where is A? A is in the first production where S produces small a capital A. Now the follow A is followed by a variable. Which variable? B. So now when a follow, we get a variable followed by the variable. In this condition, we can evaluate the first of B in the follow of A. So when we are going to check A, we can check the grammar at right hand side and we have got A followed by capital B. So capital B first. P, capital B's first is D and epsilon. So follow of A is D and epsilon because epsilon doesn't exist in follow. So if we put epsilon in the place of this B, what is followed by A? A is followed by small b. So finally we got the follow of A is D, comma B. Now if we calculating follow of B, we can check at the right hand side grammar. B is followed by a terminal called small b. So hence we reached to the follow of B. Now we have to construct a parsing table for LL1 parcel. How can we construct? First, in each and every column, we put all the terminals used in the or given in the grammar. So what are the terminals? A, B, C, D, and dollar. And what are the variables? Variables are S, A, B. Variables are put in the row. So when we see how can we insert the table, first we have to check what is the first of S. First of S is small a. So we can enter S produces A, B, B whole production in the column of A because S first is A. Now, when we move to capital A first is B, C, and D. Capital A first is B, C, and D. Capital A first is C and epsilon. Capital C, small c, and epsilon. When we get epsilon in the first, we put next entire entry of epsilon in the follow of A. First, we put A produces C in the in the column of C, A produces C. Then we jump to epsilon because epsilon is not here. So what we do is to put the A produces epsilon entry in the follow of A. What is the follow of A? Follow of A is B and D. So here we put A produces epsilon and A produces epsilon. Now in B, what is the first of B? First of B is D and epsilon. So in D column, we put B produces D. And for epsilon, we evaluate what is the follow of epsilon, follow of B. What is follow of B? Follow of B is B. So we put B produces epsilon in the column of B. Now, for example, suppose if an string is given to us ACDB, dollar shows that the string is this only, ABCDB. So how can we start? We take three columns. First of all, we have a stack. What are the input string? Whatever is given, ACDB, dollar. And the third part is action part. What is the action going to perform with this? So in the first part, stack hold dollar, that shows the stack is empty. Now input is already given ACDB and dollar. Or what is the action part? Action part is push the S into the stack. So we push the S into the stack. Then we can check now at S. S produces what? AABB. Okay. So what is the action performed? At the place of S, what we put? AABB. Why should it would put as a reverse order? Because stack has only a top ended. Means all the insertion and deletion are performed from the top of the stack. So this string is put in the stack, so it will become reverse order. So AABE we put in the place of S. Now what we checking in the top of stack is A, and we have here input is A. When we check both input symbol and stack have same symbol, then what we do, it would popped A from the stack. Now what we have? We have in the stack now B, B, A. When we see A to C, A column, A row to C column. So what is the production? A is reduced by C. It means in the place of A, what we put? We put C because of this table. When we put C, then what is the position of the input? CDB. When a stack C on the top of stack and input is C, what will do? It will pop C. Then we will have in our stack B and capital B. On capital B row and small d column, capital B row and small d column, B is replaced by what? D. Now B is replaced by D. So in our stack, now what we have? We have dollar B, T. Here, T is now top of the stack and input string is DB dollar. So what we'll do, we will pop the D, saying D to D. Now what we have in the stack? Only small b. And what is the input string? Input string is small b. Hence, b is popped out from the stack. Now what we have in stack? Dollar and end of string because dollar is here. So hence, the given string is accepted by this parser. Here is more examples is given for LL1 parser. Sometimes the production in table, we have more than one entry. So it says that this given grammar is doesn't exist in the LL1 parser. In this example, you have to calculate the given grammar. You have to create, first check left recursion, then check this ambiguous grammar or not, then check the left factoring. After checking that all the steps, evaluate first and follow, then create a table, and then you will do this. So although you have to do is to, so this example is solved by me. So if you have any doubt, please pause the video, reverse the video, and then start the video. You can easily evaluate everything and you will create a table, and then you will understand how LL1 parsing table is created and how a string is executed from this. This is some examples for you. So first you have to solve this, match this first and follow, match these examples with this video, and then stay tuned. Thank you so much. I hope you will get the best.